Okay. So Hitarth is not here yet. Ah, he's here. So we do have most people. We have at least one member on each team. So Srijata, so you want to wait for
Yes.
Shayab to join?
Yes.
Sir, actually, you put the pairs wrong. Trijato is pairing with me, and Argadeep is with Shreyas.
Is that right? Okay, sorry about that. So, so, so say that again. So Srijata is
Kapil.
Kapil.
okay, and Argadeep is the one with Shayab. So we don't have any representative for that.
Sorry, could you repeat it?
No. Neither Argadeep nor Shayak is here. So that's okay. So we will wait for them. So I had them penned to go second. So Kapil and Srijito, are you willing to go?
Yes, I am willing to.
Yes.
Can you?
Yes, I will do that. I will make both of you co-hosts.
Is it fine if only I present everything?
That's fine. So, but just in case. So, yeah, that's fine. Oh, yeah, you're Kapil. I'll make both of you. Yeah. Yes, go ahead.
Okay, so can you see the board?
Yes.
Okay, so I'll describe a game called Octopound. So it is played on a 4x4 board. Can you see? You can see here from A B C D
Yes.
and 1 2 3 for only that thing. And what happens is they are just regular chess pawns. Like you can play like this, and then you go like this, this, uh, this. And whenever a pawn reaches the last rank, that side wins. Okay. And another way to win is that uh, you should another way to lose is that there should not be any move. You should not be able to make move. Like a condition like this can happen. Here white loses because it does not have any move. Okay, so our project idea was
So the things don't move crosswise like in checkers, is it? So so
They
usually
can
they
capture other piece if it is
can capture
diagonally
other.
opposite.
Like if you play like this, if you play like that, you can capture.
uh, or you can move diagonal also, correct?
You cannot move.
Only if you
No,
capture
no, like
another
you
piece.
can
Only for
capture.
killing people you can move diagonal.
Yeah, only while capturing you are allowed to move diagonally. Like you cannot move like this. So what our intent was, first we need to generate the training data, for which we will use Minimax algorithm to solve this game. Okay. And then we'll train a neural network and we check a property, something like if say a pawn is here and it's white move, then he must win, right? He plays this and
So
reaches the
how many pawns are there?
4 pawns each of each color.
For an 8x8 thing. Yeah.
Yes.
Mm.
So if a white pawn is on this rank and it's not obstructed by pawn like this, say the pawn is somewhere here, then you can play this and win. So we can check this property. So we want to basically find out whether neural network can identify that this is the winning move. Whenever a pawn is on second last rank. Can you hear me, sir?
No. I'm just thinking. Yeah. So the thing will be you have a definition of what a good move and a bad move is,
No,
and the
actually,
neural net is
finding a good move on any given position is actually hard to do. I think it's like whenever a position like this occurs, this is a we want to classify whether a position is winning or not. That's all. We will not classify whether move is good or not. Okay, sir.
yeah. Say whether a position is valid, whether a configuration is valid or not, is very easy to check just using an SMTZ3 itself. I mean, they're only finitely many. So is that all that you're doing? So whether the next move that you make will, I mean, if what is the neural network supposed to advise you that?
Neural network is supposed isn't supposed to advise. It's supposed to classify whether a position is winning or not. Means, uh, like
How do you know in one step whether he's winning or not?
you do not. We will use the training data for that.
Yeah. So the neural network has to suggest a move, correct? And
No, that we haven't yet.
but then
Like
I
it can just you can just brute force over all possible next configurations
do you
to
understand it?
see.
I don't. I mean, you. What,
Yes, so after you train the neural network for a given configuration, you can just loop over the next possible moves
so you're
and check
asking
which
the
one of
neural
them is
network
winning.
advice to which of the possible moves that you can make.
Yeah. So I am saying once we train the neural network to determine whether a position is winning or losing, just using that neural network only we can determine the next move because we will try all possibilities for the next move and see which one of them is winning.
Actually, we didn't decide whether train a neural network to suggest a winning move. We just want to classify whether a given position is winning or not.
So a winning position is like that the pawn has reached the other end, right? So isn't
Uh,
it like
yeah, there are
yeah?
two types of winning positions. One is like I'll show you. If
Mm-hmm.
something they goes like this, wait, like this, then white doesn't have any move, right?
Mm-hmm.
So black wins.
Okay, so by winning position, like this, but these particular kind of structure, let's say configuration, are like very easy to check. Like you can just
No,
like
you can
that.
even generate using Z3 for any particular thing.
Yeah, in
What are
finally
the
we'll use
things?
Z3
What is
to
there to check? I mean, I can solve this just like Sudoku. I can give you the solution. I mean, here also this particular thing, whether the next move is, where you will.
no, we want to verify the neural network, right? We will verify whether the
No,
neural
but what's
network
the purpose of
identifies.
neural network here? I don't understand. See, neural network is supposed to, if you could, you can actually using Z3, you can check whether the next one is.
No, sir, it's not is possible to use Z3, I think, to evaluate a given position. We will require something like minimax at least.
I agree with that. So you're just checking if. So from here, what is the neural network will classify?
So given position like this, neural network will classify whether this is winning or not.
Winning
the
with respect
So
to
a
what?
in the
position
next
can be either winning or losing. There is no draw.
It's the deterministic finite game. So from every position is either winning or losing, and we want to check
That's what I'm saying. So
this.
Z3 can check that whether it is winning or losing.
It will be very difficult for that. I think.
Why? Why will it be difficult? You just by saying the difficult, it is not. I mean, I can tell. I mean, there are only so many configurations here, correct? In any particular given a
I think there
particular
is
configuration.
somewhere around 10,000, 10,000 to
Uh,
1 lakh position.
sorry, I think there's been a bit confusion. We are not saying whether or not it's winnable from one move. We are saying given a general configuration, whether it's winning or losing.
Okay, so it means that you are not talking about the next one or two move. You mean
Yeah,
that
yeah,
at the game will it be winning or not? That's
Yeah,
the
If
thing.
the
like see,
if a gen,
given this move, it should predict that white is winning.
Of course,
Actually,
that
white can
because you
win from this.
okay. For these kind of thing, network can give wrong output because this is the initial configuration of the game, and you know that as you mentioned that this game is there is no strategy that has been published for it, right?
Yeah, yeah,
Yeah, it means that it won't work. Your network won't work on this particular configuration, but your hope is that it will work for other configuration, which are let's say
exactly.
easy.
Like if a pawn is somewhere here, then at
Mm.
least here it should predict that white is winning. That's what we want to verify.
But how do you check whether it's correct? Like you have to somehow run your network and get to know what is the best possible, like which one will
So we will use
win.
Minimax to solve this game.
So that min-max will solve it like
Yeah, yeah,
deterministic.
it will solve everything. It will for given position, it
Mhm.
will always give you whether it's winning or not. And that is for sure. And we'll use that training data to train the neural network.
So is this problem like deterministic? Like
It
one
is
can
solved
always
problem.
determine
Yeah,
this?
it is kind of solved problem.
It is a solved problem. Like people can definitely check whether white will win or black will win, right?
Exactly. Yeah.
Okay.
What I was saying that by using Z3, I think it will be very hard to do. Like given Z3 this input
Mhm.
and
Because you don't have the number of moves that are left. Like it could be anything, and that's why you're saying that Z3 would be it would be hard for Z3, right?
it will be a mess.
No, no, no. See, the way he described it, this is the
Mhm.
problem. If you don't write it up, it's very difficult. The first time, to take. You were not predicting a good move or not. You're not. See, from a okay. So, is this configuration winnable or not? Is that all what you're checking?
Yes,
So
yes.
from here, is this okay? Give me. So in this, you have this configuration now. Okay. What is it that you are predicting?
It is we will consider only those position where it's white to move.
Where is what?
Where it is white to move, it's white's turn.
Okay.
And we will try to find we will train a neural network to identify whether that position is winning or not. Means
Is what is
there are
winning?
two options. One is there is a winning move, and every move is a losing move.
The losing means in the next step you will lose. Is that right?
Every move you play, you will lose. And winning means there exists a move which will let you win
Let you win in several steps.
in several steps. Yeah, not in one step.
Okay. So not in the very next step. Okay.
Exactly. Like this is
Yeah,
not
but
like
when I
this is
say
a
are you suggesting a move that will eventually win, you say no, 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 no. Okay, that's why I get confused.
okay, there was confusion. Okay, I agree.
Yeah, I mean, if all you're doing is, oh, what is the next move? Okay, so then it is going to suggest a move so that will let you eventually possibly win. Am I right?
Yes, means it will tell you whether
yes,
the winning
yes,
move exists or not.
yes. So this is just a finite game with terminal states well defined a bit. So every configuration is
If you are
either winning or
confused,
losing.
even now I'll show you a game like
TikTok,
you play this.
the Madhukas TikTok was also like that only. So, and there was a notion of what a good move and a bad move is. At each, he defined it. Now here, you will, how will you train this? Okay, by showing a whole sequence of moves.
No. We'll just give the configuration and ask neural network whether it's winning or not.
Is it winning or not?
Yes.
After that,
we'll use Z3 to verify our neural network. Like if a pawn is on the second last rank.
no, but if a particular from a, I'm still very confused. I mean, Madhukar, do you understand?
Yeah, so I understand what he's saying, but I don't think that's very interesting.
Not even, I don't even see. Is he checking just whether the next move gets him a?
No, he's checking whether from a given configuration there is a way for white to play and win or not.
Yeah, but then how can he do that just without showing a sequence of moves?
No, so he'll actually in his
It's just a
training
property
data,
of the configuration, right? So I'll feed the training data into.
so his training data will be a configuration,
So
whether
his
it was
training data will
possible
be,
for.
if there is a move for the white from this thing, regardless of what the black does, is that what is?
Hello, sir.
Yes,
Yeah.
Professor.
It
So
depends on what the black's move is also, no? So that's why I say, how can you, without actually showing a sequence of moves, what the other person's move is, how can you even say that there is, I mean, you could say that there exists a move.
I mean, you will assume after that players will play optimally.
Kapil, if I'm getting correctly, then the number of moves is bounded by 4. Is it like
Yeah.
you cannot
Yeah.
4 moves in the game?
No, not necessarily. Like this is one more, this is
Yeah.
second more.
Okay, Kapil, I mean,
But-
I have, okay.
Fourth more, fifth, sixth. There are 6 moves in this game.
But there will be some like limit to it, because every time one is like
There will
moving
be
forward,
some limit for sure.
like it's 650, a small number, of course, right?
Exactly.
So the question the question that you'll be solving is that, does there exist a move for white such that no matter what black plays, will there be a move for white such that no matter what black plays, and that
Exactly. I mean, if they play optimally, given position is winning or not.
correct. So then you will train the neural
For
network to.
example, this position is winning for white actually. If white plays
This
optimally.
position is winning for white regardless of what black does.
Yeah, exactly. Means if both play optimally, it will white will win.
Professor, I think he's training his network. He's thinking that his intuition is that the network will figure out somehow that, like, without giving the number of moves that are left from the given configuration, the network is supposed to tell whether white can win or not. Like, we are not telling it how many moves are left. His hope is that there is some pattern in the configuration which can, which we cannot figure out very easily, but there is some pattern hidden in it that can tell you whether white can win or not. And then he will verify the properties, like from using the
training data. If all is given to the training data is, with this, or the outcome is white is winning. Okay, so he'll give several configurations like that, where if each of them played optimally, that once one will win. Okay, is that right? So that is deterministic with respect to the position.
Yes.
Okay, so each position, each configuration, there are so many, has always, if each of them plays optimally, there is a deterministic win-loss.
Exactly.
For for one. Okay, and so, but by just feeding that training data, still the network will have to suggest the moves, correct?
Yes. No, we didn't consider that extension, suggesting moves. That will be.
But then if you don't consider that, what is the network is output supposed to classify? It just classifies
It just classifies
Yes,
It's
whether
winning or
this
losing for white.
configuration is winning or not.
yeah, exactly.
No, I don't think this is.
I think we can come to this at the end if we can, because
Yeah,
15
I
minutes
think
up.
so. I
So
think this is the first time we're seeing this. It is difficult. Okay. So we'll have to discuss offline, Kapil. Okay, about this. How whether this can be how this can be made. So let's move on since I have limited time. Okay. So I'm not convinced that this can make a good thing.
Correct. Yeah. So just one remark. So at least, see, if the network somehow believes that a move is winning or it is not winning, it should at least give a reason why it believes that, and then we can check whether what is going wrong with the reasoning. At least it should do that much.
by reason you mean that it can give you next move, right?
Yeah, it should. So
Yeah,
if the board is actually, if the configuration is actually winning, but the neural network is not thinking that it is winning, it is certainly playing one move which is wrong, which is non-optimal.
Hmm.
And we should be able to get that automatically and identify that this is what the network is thinking, and that's not correct. This is the non-optimal move that the network is making. At least that much we should be able to do with this.
Madhukar, I think he's not even like talking about moves yet. So maybe
Correct,
we
correct. Yeah, so we can come
so
back
we
to
can,
that. Yeah, yeah.
I think there is a there is a window that you can expand this and make it better.
Certainly,
But
certainly,
let's
certainly.
discuss it at the end or later. Let's move on.
Yeah, yeah, certainly, certainly. I agree, I agree.
Okay, so on the list was. So can you unshare? Is Argadeep here? No. So neither Shaik nor Argadeep is here. Okay, so then we'll move to Deeksha and Somadev. So they had submitted. Okay, so I'm going. Who's presenting? Deeksha, and I'll make them both since they're not answering. So I will make them co-hosts. Okay, so Deeksha and Somadev, I have made you co-hosts.
Yeah, am I audible? Hello?
Yes, very much
Yes.
so.
Yeah.
Yeah, we've kind of reviewed your. Go ahead. Yeah.
Yeah. So this is the first proposal that we made.
You have to speak up a little bit.
Yeah. Am I audible? Yeah.
Yeah.
So the problem is basically we take a noisy signal and we try to find the frequency of the signal. But if we try to do it manually without using any neural network or something like that, then we have to use like Fourier transform or
Shomodev, your voice is breaking a lot. Is
Yeah.
it like
Some connection is bad. So you kind of come clearly and then you go back. So maybe you're.
hello. Hello.
Yeah, you are audible. You can go ahead. Just speak a bit louder if possible.
All right. Yeah. So yeah, the problem is basically we want to try. We have a noisy signal, and we are trying to find the frequency of the corresponding signal. But so why are we using neural network for this? The first reason might be when we are doing it manually, we would have to use something like hello.
You go ahead.
Go on. Shomadev, you can go on. You are audible to us.
Yeah. Uh,
Are you there? Um, oh God, I don't know what the problem is.
Yeah. Uh,
There seems to be some problem with his network, I think.
can maybe we can communicate through chat. So he's not even probably
Yeah, let me.
Hello. Hello. I'm audible now? Hello.
You're back. So so far you're completely
Oh,
okay. Yeah. So you're audible now at the moment.
all right. Yeah. Yeah. Oh,
Oh,
sorry. My net connection. I don't know what happened.
ah,
It's
so,
fine. Just
yeah, it's
chill.
fine.
Don't be nervous.
Yeah. So basically, we want to, yeah. Basically, we have a noisy signal and we want to we are trying to find the frequency that is corresponding to that signal, right?
Mhm.
Now, we are using neural network because if we do it without using neural network, then we would require uh, something like a Fourier transform or um, least square method, something like that. But here, what we are doing is we are basically feeding the neural network some sampling data. So, what is the sampling data? A sampling data is basically the number of samples that are taken in 1 second of the signal. Hello.
Yeah. Then please go ahead.
Yeah. So from the sampling data, we are say taking some microseconds, and we uh, say say we take 10,000 or say 1,000 sampling data within a given time frame, and that will be our input for the neural network. And then from those data, we are trying to find the frequency. So how will we calculate the frequency? We'll just take this formula of the sine wave, and since we are already having the amplitude, the time and phase and everything, so what we need to calculate basically is the we also need to determine the noise that is being associated with the sinusoidal wave, right? So to calculate the noise, we are basically checking the signal to noise ratio, which is the amplitude divided by the variance that is associated with the network. I mean, with the signal. So uh, this ratio can also be represented by in decibel using this formula. So from this formula, what we can get is the variance, that is basically the noise that is associated with the sine wave, right? So basically we can calculate given a network, given a signal, we can calculate the frequency in this way. So generating the training data and the validating it is done.
Yeah. So you can write a program
Yeah.
to do exactly what you described just now. Correct?
Yeah. Yeah. So we take the sine wave and we take some timestamps, and then say some 10,000 samples from the sine wave from the formula itself by taking some timestamps, and basically we take them as the input of the neural network, and we calculate the frequency thereafter and check whether we are getting the correct frequency or not. So we can set the range of the frequency, say some 1 kilohertz to some 10 kilohertz. And since neural network works better on something like discrete values from 0 to 1, we can just normalize the data, right? So what are we going to verify from the
No.
network?
Before, see, this is kind of the problem that briefly Hitat had suggested, correct? Uh,
Yeah.
is one of the problems. But
Yeah.
why? I mean, you already, okay, training data you could generate. What is the advantage of doing this problem, solving this problem through neural net?
Yeah. So basically,
So the output, the neural net, what does it classify? Okay, it brings, okay, given some sampling of the signal for up to 1 second or whatever the time frame that you have, is going to so sampling, it is going to put out a bunch of some range of frequency, correct?
Yeah.
So there must be some restrictions. Okay, so obviously but that range, is it always going to be bounded? Will it always be some?
Yeah, if it is, so we know the frequency already, right? So the range of the frequency.
No. I'm not talking about generating the. Yeah. So.
Yeah.
So why should it be always 0 to 10 or something like that? Why? What is the range of the output? And what is the number of classifications that you get? Why should that be a finite set?
Sorry, I'm adding it here. Maybe he actually said that the output would be just one single frequency of the signal that you want to. That is the frequency of the signal. That's it. There's a single output to this.
Yeah, that's single output.
But that, depending on different inputs, can be different, huh?
Yes.
Yeah, but so I'm saying your output could be. Usually the neural networks that you're talking about will be, usually it classifies. So it can be, here that the output, the number of output values is infinite, correct?
No, there is no classification here. So it's actually calculating the value of the frequency. It's not a classification network. It's just a calculation kind of thing.
Yeah.
It's calculation. So there is always a definite answer here. Huh? So the neural network, so why, if you can always calculate it, why can't you what is the advantage of using the neural net here?
So the theoretical methods that are used are some discrete Fourier transform or something like that. D-square methods. So they are quite tedious to work out, right? So neural network, using a neural network, it is kind of a one-time thing. So the result will be like faster than calculating it manually.
Yeah, but here usually the accuracy, etc., is determined by, you can't have one extreme data, the other in some other extreme data, and then you expect the neural net. So it is quite sensitive to the training data. You will have to, depending upon your training data, will have to be well distributed, correct, over all different frequencies and so on. Otherwise, the network might be hopelessly inaccurate.
Yeah. So we can train the training data should be like say 50,000 or something like that. Then
no, not only the number, but what I'm saying is all of them cannot be signals whose frequency is all very, very close. Okay.
Yeah, it should range from like, so
Okay.
we can also constrain the the neural network to some frequency. I mean,
Yeah, yeah. No,
yeah,
but then that needs to be defined as part of your problem. Okay. If
yeah.
indeed you want, that's why I was asking if there is a bound. Okay.
Mhm.
The lower and upper bound that you want to define as a parameter for which you want to train. I
Yeah.
mean, you want to make the neural network.
Otherwise, it will be too vast to like
Yeah.
predict.
Okay. Yeah.
Hmm.
So now I'm getting it. As certainly I can see. Yeah. Yeah. So you'll have to generate this training data, and it has to work well on a new test data, which is kind of maybe within that range, but it is different. Correct.
Yeah.
So yeah.
So
Yeah, I mean, I understand the problem, quite well, but what kind of training data, what are the limitations that you want to impose on your, problem, okay, in terms of the range of frequency, etc. They are important,
yeah,
for you to do, have to be defined, okay?
we can
And,
actually uniformly distribute the training set
hmm.
in order to get a better result.
Okay, what I'm saying is, as part of your proposal, please define those things. And what is it that you will verify?
Sorry? Yeah. So we can verify a lot of things. So some possibilities that we thought might be something like this. What can be the maximum noise of a signal such that the network predicts the frequency to be some plus minus one of the actual frequency? This can be verified. Also, we can also check whether some noise is so absurd that the range of the frequency is like not even close to what we wanted, or the range in which we are training the data is, it is beyond the range of our training set. And also, we can just flip the signal. And also check whether it is working correctly or not.
What do you mean by flip the signal?
So by flipping the signal is basically you
Hit
take
the minus. Huh?
yeah,
Oh.
and yeah,
Okay. Okay. Some variations that if you do the frequency.
changing the amplitude also should not change the frequency.
Oh.
So we can just you know do some print in the amplitude and check whether the frequency is intact or not.
Yeah. Yeah, I think the important thing is for you to make this problem complex enough, okay, but not too complex, so that the verification, it will stress the Z3, the verification,
Yeah,
and at the same time that it will, your problem of getting a suitable neural network will not be too onerous, okay?
mm.
But it has to be, yeah. Yes, what is the kind of accuracy that you get so that, getting, since Siddharth suggested this, I don't know how, this problem, I'm sure this problem is, there are solutions, correct, Siddharth, for this?
Yeah, there are. Like, we can find that.
Yeah, for getting 80% accuracy, etc., or better than that, what is the, do you have any idea of what the complexity of the neural net is like?
Yeah, I think even if they use like 600 sampling points for this input, they can achieve very well like 85 to 90% of for the accuracy.
Yeah, I mean, in 600, network with 600 nodes, etc., that is also challenges, I'm sure, Z3. Yeah. Okay.
Yeah, it would be a bit challenging, but I think like that's where their work will come on. Like they have to somehow figure out how to like make it work. Yeah.
Yeah, so this
Yeah.
is a good one. I think it's a reasonable one. I'm sure we'll also hear Diganta's and company, Diganta and Shogata. They are also I think this, when they speak, they have suggested of using this as an application, but they are approaching it in a slightly different way. So I'm okay with this being also used by another team. So I think I'm okay with that. I mean, yeah, Hitat and Madhukar. So I'm okay with that. So I think some parameters, etc., will still need to be specified clearly. Okay. And the formalization of these properties will have to be made. I mean, generally what we were discussing, so we want maybe about, at least half a dozen, 6 to 8 kind of interesting properties to be identified and verified. These properties will be somewhat application dependent, within the category of correctness and robustness. Things within those categories we would want you to do. And also, when you're identifying properties, some things, at least some of them might make sense. Okay, certain bad things, like if if it is classifying certain things, when you do it, that certain things should never, extreme inaccuracy should not happen. Okay? Yeah.
Verification is somewhat like that.
Yeah. Correct. Yes. Okay. So this is good. So yes, I mean you've also written. Yeah, I think that part, although you described in your proposal the second part more in a more detailed fashion, you have to add more details. Okay. In your proposal, I want it to be in what the inputs are, how you generate the training data, etc. You've described it here. Make it part of your proposal. That's all. Yeah.
Sure.
Yeah, and also it is for everyone that one should try to have at least 6 to 8 properties to verify to make it a bit less trivial.
Okay.
Okay.
Yeah.
Yeah.
So who's up next?
This is on my list. It is Hrishikesh and Anantu. Okay, so let me.
I'm sure. I'm stopping my sharing. Yeah.
So do unshare and.
Anantu, do you want to go or Rishikesh
Yeah,
will be posting?
I'll be sharing.
Okay.
I means who? I made both of you.
Okay, sir.
Yeah, you are made co-host.
Sir, I still can't access, sharing.
I'm not done it yet. Here, sorry. Now.
Yes, sir. Sir, can you see it?
Yeah. You can see, yes.
Okay, so like if you see around, like India is a large country with a huge population, and there are like many different languages in India. So like if you see, all of us use smartphones, and I guess most of us are really addicted to something like WhatsApp or Facebook or Instagram or something, and we chat a lot. But the main problem is that if we look into it, most of us, not everyone, but still most of us chat in a way, like want to chat in their local language, but due to some problems, they don't get a perfect keyboard in their local language. Like if you see, Malayalam has many characters, so I don't get a local keyboard, proper local keyboard in which I could type Malayalam. So what we instead do is that we try to convey the things in our local language, but we write in English. Like if you want to write something like bye, we will be writing BHAI. So we were thinking something to like solve this problem by like there are some features like that, like you could write on your screen in your local language, and the mobile will automatically read what you're trying to convey, and they will convert it into the digital form, and you can send messages. So for the project, we are planning to do something similar. We'll be creating a neural network, so which can predict what we draw or write. So first we were actually thinking about something like shapes, which Hitaj suggested. But then after what Sir said, Sir gave a suggestion, and like we are thinking to try it with some characters in a local language like Malayalam. So we'll be like training, like we'll be giving some hand-drawn Malayalam characters as the input, and like we expect our neural network to understand what we have written. So like we are planning to like create the test data and training data. Like we think that it is easy because you can just give some hand-drawn things, and you can just enlarge the size or tilt it by a small angle, and I guess by doing all the combinations you will get a lot of test data and training data, so we could work with it easily. So then about the properties that we want to verify, we are thinking something like a character or a letter when tilted by a really small angle, like 1 degree or 2 degree, it should give the same thing. Like if I write something like a car slightly tilted, it should read same as, I mean, it should even then read car. So that's the one property we want to verify. Then we hope something like color correction, like if you write it in blue, red or black, anything, it should read the same thing. uh, Also we want to show that like some letters, they have the space inside the letters, like a some letters. So increasing the space or the size does not change the uh, like does not affect the network, and the network reads the same thing. So we were planning to do something like that. Hello.
Yeah.
So that's it.
Yeah. Yes, we did discuss the thing. So do you think, yeah, and I know I did make the suggestion to use, certain, some characters in the Malayalam alphabet or any local language, specific local language. But there was some concern that will that be too hard? Okay, what was your concern, Hitarth? That
Yeah, it was because if you were drawing a character, let's say, I don't know in what kind of characters in Malayalam, but they might be, you need a resolution. Let's say you need 30 by 30 of size of image for that. As far as I checked on DigitNet, it was not possible to check even 28 by 28. Even 50, like 20 by 20 was very hard for Z3. So the only concern I had was that how one would actually make it work, like the verification part. Recognition is like easy. It's not a big deal. But working with like Z3, that might be a pain. So that's why I suggested that he can work with the shapes instead of like, various shapes uh, and so on, like instead of sticking to characters for now.
But there I want to understand, Hitat. I mean, you're
Yeah.
saying that to recognize like real characters which have, so the strokes, etc., that you will have to be a lot more. Is it so that you want to? Okay, therefore,
Yeah, so to preserve those very minor details, you have to have a good resolution for the image, and the resolution basically means the number of input will increase a lot, because you need to have, the image size will increase.
correct. So it
You
means
cannot
that the node size will also go up.
Yeah, that's the thing.
For
And
getting
that is the key
comparable
problem.
accuracy, reasonable
Hmm.
accuracy. Yeah, that I can see. I mean, they can start by doing it, but I think I maybe extending it to some characters. We can pick some. Would it still?
Maybe we can like add some like relatively like simple characters.
Yeah. So
Yeah,
we,
so basically, even having rectangle, square, circles, and so on, lines and whatever, you can also have these characters. Like they are basically shapes, isn't it? So I mean, that will still work.
correct. I've seen Malayalam characters. Tamil characters are even simpler. Okay, so Malayalam is a little bit more complicated with the curves and so on. So maybe you can select some which are straight line things. Some of which are like that, isn't it? So
Sir, may I ask a question to them?
yeah.
How are you exactly? How will you encode image in Z3? Like there will be several images, right? How do you encode something like rotating in Z3?
How do you encode the property? You mean?
Yeah, I mean, you will take an image, but how you encode it in Z3? Like, will you be storing pixel by pixel values?
Mm-hmm.
Because if you will be doing that, the image will be very large and the number of variables will be very big. So you need a smaller resolution image or something other like that. But then you will lose. If they are hand-drawn images, you will it will not look clear, I think. If you
Like we were actually planning for something like 10 into 10 pixel shapes or something, but since sir suggested something today, so we didn't actually look much into how to do the Malayalam things. Like we were planning to do just some simple shapes.
Yeah, I think it's better to take Hitat's thing and to start with simple shape. But
Yeah.
if I understand Kapil's question, his question was how you would, not how you would give the inputs, okay? Input and, your input will be some set of pixel values. So if I might understand, Kapil, your question was how you would model the fact that one image is rotated by a certain degree of another
yeah,
image.
that was an example. Like means
How would you model that? Let me finish. How do you model that in Z3? That is your concern? That
yeah,
is what,
yeah.
yeah, but that can be modeled because you don't require, so if you have, of course you have to have as many variables as for the pixels, and then you will have to have twice as many, and there must be some relationship that you will have to express between the two, saying that if you rotated it, if certain x1 was had a certain value in the original image, x2 the corresponding thing will you'll have to relate that to the other things, no? That's how you would specify the rotation. It will be a relationship between two sets of values. So it'll, using, that's how it will be. This is just a certain kind of perturbation, that's all. I mean, yeah. I mean, there's another question of how will you generate these rotated images as part of your, no, but that is not even needed. For training data, you don't need that. Okay, so, correct? Alan, so, you know, the training data will just be on images, but
Yeah.
the rotation property will only be specified and verified in Z3, correct? Huh?
Yeah.
I mean, yeah, I've not completely answered Kapil's question, but that is something that you'll have to think about. Exactly how do you specify? It will be a constraint, a relation on two sets of images, each of which will have to use certain number of variables, and that's how it has to be. So the difference, you know, some kind of has to be expressed as some difference between the two.
Yes, sir.
Yeah. Yeah. Okay. So, I mean, I would still go and try to go beyond the just the shapes. Okay. Start with the shapes. Huh?
Yes,
And,
sir.
you know, some, you know, even with shapes, what are the shapes that you would start with, that you would suggest that you would,
Something like circle, square, rectangle, line.
yeah. Yeah, but pick some variations of those shapes so that they can be you know, somewhat relevant to describing some characters in that
Yeah.
choice. And that should be fine. Yeah. Okay. Any questions? Any other people? Okay. So Diganta. Inshallah.
Yeah.
Just a moment.
Yeah, okay, so I'll share the screen right now. So
I hope you have gone beyond that, what we had already discussed, which you described in the para that you sent. Huh?
yeah, so I mean,
Yeah, present whatever that you have. I mean, that's unfair. So you present and we'll ask you the question.
yeah, okay, but yeah, yeah, okay. So if my screen is visible right now,
Yes.
yeah. So okay, so basically, I'm sorry for like I couldn't make some slides, but I'll just use these to present if that's okay. So the property that we are interested in is the invariance of the neural network under certain permutations of the input. So that would be if n is your neural network function, something that takes say x1, x2, x small n to some y, then we are interested in properties of the kind where if you do some permutation sigma on x1, x2, x small n, and then do n, it should give you the same result as the original n. So we're not the values that sigma can take, the kind of permutations that we allow inside here. It's not all of the permutations, but it's some cycle, like some member of some cyclic subgroup of the group of all permutations. So it'll basically be of the form of some g to the power k, where g is some permutation. Right. So the reason why we're sort of interested in this is because we found it several different properties, and we'll give some very concrete examples soon, are sort of can be expressed in this form. One of them is the rotation of images, because you can sort of think of rotation of images as cyclic permutations of pixels. Another interesting, a very direct sort of way to property that can be seen as that is of this form is the rotation of any kind of polar data. So if you have some data which is, say, something that, say, okay, the example that I had in mind was something like a LiDAR scan, say. So if we have some data that is like this, then say for each of these radial lines, you have some value, and then you're using that and feeding that into a neural network to decide something. Then each of these radial lines represents one input. And if you rotate your scanner a little, then these radial lines get permuted cyclically, right? So this line goes to whatever is the last input here. The second goes to the second, the second goes to the first, the third goes to the second, and so on. So these are like two examples of why this property is interesting. Another example that we'll go into into a lot of details is basically similar to one of the other projects that we presented here, which is the frequency counter example. So we're going to go into that. So for the frequency counter, if we have some neural network that is taking in an array of samples and is trying to, say, count the frequency, then we would expect that that array of samples, say, for example, if your array of sample is this and it gives you some frequency of f, we would expect that if we were to add some phase to the signal, then the frequency should be the same, right? And now addition of the phase, that corresponds to a cyclic permutation of your sample, because if you add, say, a phase that corresponds to shifting the time by 2 sample lengths, then the first sample now becomes the third sample, the second one becomes the fourth, and so on. And the last one becomes the second, and the second last one will become the first, and so on. So again, as we see here, that the phase invariance of whatever the frequency counter is can be thought sort of as a property of this form. So the phase invariance properties also looks like this. In fact, another property of this particular problem, the frequency counter problem, also looks like this, which is that if we sort of know that the frequency counter is giving us some frequency f, and if that corresponds to, it's really hard to write with the mouse, but yeah. So if you have some frequency f, and if that corresponds to some time period t, which corresponds to, say, these many samples, then if we take each one of those samples, each one of those cycles that are repeating, and permute them in a similar cyclic manner. So we send the first one of each cycle to the second one of each cycle. So this one will go to here, this one will go to here if the cycle is this, say, and then this one will go to here, and so on. And similarly, the second to the third for each one of them, and so on. And again, last to the first, right? So if we do that, then we will be that is also another way to express another property that should hold for the frequency counter, is that if you do this, then it should give you the same result. And this can also be expressed as invariance under some permutation. So this was sort of the motivating reason why we wanted to check invariance under a permutation. And we had also thought of some other properties of the frequency counter case that would be interesting to see, but I do not think that we should probably, given that someone else is also doing a project on this, maybe I'll not go into too much details of those. But yeah, so this is the idea that we had. And now, so our basic idea of the project is to sort of go into and find a very general method of verifying properties that look like this, and then use that general method as an example, or as an application, use that general method to verify these property 1 and property 2 of neural frequency counter, let's say. So yeah.
So one question that I had already asked you the last time when you presented, just for us, this one, so was, see, this can be done at 2 levels, this verification. I could say that this can be done at an abstract level, for lack of a better word. I mean, at the level of, suppose n is some function that maps r to the n to r to the n. okay, or maybe R to the
Right.
R. Okay?
Right.
And then you specify what your cyclic group is, and you specify sigma and G and so on.
Right.
And so what are the kinds of things that you get? Or maybe N is a linear relation, or some pseudo-linear, piecewise linear relation, a class of N.
Right. Right.
Yeah?
So
So without actually getting into any of the details of the neural network, you could set up a framework, a verification framework, okay?
right.
Which will be maybe some set of strategies built on top and using Z3.
Right.
Maybe it is unlikely that, depending upon Z3 will be able to solve it. Okay, if you're able to solve it as a single SAT instance, it's fine. Otherwise, you may need to do so. That is one level, and then when you apply it to a particular neural network, the
Right.
will go up because N will then involve the structure of the neural network as well. Okay?
Right. So
Yeah.
so the level in that sense, the level that you.
Let me finish my question.
Yeah. Okay. Sorry.
How do you plan to do it? Because after all, just doing it at the first level will not be enough, okay, for the purpose of this project, because you'll also have to demonstrate it on some neural network, okay?
Right.
Or actually, because you're proposing it as a general framework, maybe you'll have to demonstrate it on a couple of, at least a couple of different neural networks, right?
Right.
So what is your plan there? That is the question.
So yeah, so let me say firstly that in terms of the actual generality of this framework that we want to find or make, the neural network, we will basically assume the neural network to be some. Okay, so let me just join a new page. Yeah. So we will assume the neural network to be some abstract neural network itself. We will assume only two things about it, that the neural network takes Rn to R. R is just for simplicity's sake for now. Maybe later on we can look at Rm, but for now let's look at this case. And we will also assume that the neural network uses ReLU, not any general activation function, because I have some ideas of that we hope that will help us to exploit the fact that ReLU is piecewise linear and so on and so forth. So under this, any deep neural network, like any sort of your standard neural network with say k many layers, and each layer is having ki nodes. If any neural network that follows some k and ki, where k and k is not fixed, it can be anything itself. So our framework should be applicable to that. So that is the level of generality that we are hoping to target.
Even in the framework, at the first level that you talk about, you would express N in terms of these smaller functions, which will be, so N would be composed in terms of ReLU and smaller linear functions.
Right, exactly, yeah.
And so on. That
Yeah.
structure you would...
yeah, we will assume that structure. So that is the basic neural network structure, right? So if we think about neural networks, the only thing that any other general neural network can have differently is maybe we can have some other activation than ReLU, right? But every neural network does look like some input and then a linear transform and then some activation and then linear transform again and so on, right? So that is the structure that we are planning to assume, yes.
Yeah, and then after that, you will instantiate this for particular...
Yeah, so the problem that we have thought about instantiating it for right now is these two, basically one neural network, which will be the frequency counter neural network for the signal. And we'll instantiate it for two different properties for this neural network. One is this property 1, which will be the phase shift, and the other is this property 2, where permuting, cyclically permuting each period, if you will, should give us the same frequency.
Diganta, I have a question here. So
Right.
this this cyclic, whatever you're doing, this swapping and all, it depends on the frequency, really, right? So first you
Right, yeah,
calculate
yeah.
frequency and then you apply this operation, right?
Yeah, so the second one does. The first one is independent of the frequency, but the second one does.
Yeah,
Yes.
this one,
Yeah.
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 Okay.
So I
In
mean,
the first
we'll
one,
yeah.
wait, just one more question. In the first one,
Yeah.
can you go back?
Right. Yeah.
Yeah, in the first one, when you shift it, so what do you put in the? Okay, you put the last value. So you are like,
Right. Right.
okay, the last thing is coming first. Okay, all right.
Right. So I mean,
Mhm.
the assumption here is that this signal is like we've sampled it for only say some t amount of like some small amount of time, but the assumption is the signal goes on for infinity, you know, and that it is indeed somewhat periodic. So if we shift the sampling, we're actually like whatever we were seen at the end would now come to the beginning. So it's like, yeah, if you the motivation behind this property is that if you have a signal like this and your sampling window is somewhere here, and you know if
Yeah,
you add a
shifting it
phase to
won't.
the shift, yeah, if you add a phase, then it becomes something like this, right? Is that
True.
yeah, yeah,
Yeah. But I'll go back to the question, Diganta. I mean,
right,
okay, because the see if the emphasis of your work, the project work, is on developing this the proof framework. Okay?
right, yeah, yeah,
Then is that where then in order to show the effectiveness of that,
right,
so where is your primary effort going to be at? Then you will have to show overlook by having proven this once, I should be able to exploit it in applying it to different networks. But that is not what you're doing. And your emphasis is still on you don't intend to prove some general properties about any neural network, do you?
so specifically what I want to do is I want to develop some method that given any general neural network will hopefully either give me a proof or a counterexample of a property of, you know, this form. So if I can do that, like I'll do that with some example in mind, and the example will be this. But whatever method or property that we do come up with, we can use it for say, any other neural network. So
Yeah, the reason
at
that I'm
the
asking that is because
yeah,
is
so I
yeah
think
because
yeah,
you know, where is the effort? Okay, see, in evaluating this project, if you don't get some general framework, general results there, you would then have to show that, okay, for example, the other team that has chosen the same thing will I mean, they will be spending more time in getting the accuracy up and so on, you know, and then it probably equally divided between the two. Okay, the effort of designing and getting the network up to that accuracy, and then showing this thing, whether they'll be developing some general framework, probably not. So they'll be completing the verification. So in your case, will you give equal weightage to both those efforts, or
so I'm hoping that I'll give more effort towards generating, like developing this general framework, and um, like that would be the main focus of this. But yeah, but if that fails, then I don't know where to go. So that
yeah,
is the only
if
thing.
that is the case, then then you will have to actually see. I mean, you have to pay some attention. I mean, you'll have to show pretty quickly, like we have some interim deadlines, etc., which we'll be announcing later on, within a week or so, that there is some general verification results. Neural network independent, specific design independent, okay,
Right.
framework that you can get. And
Right.
then I mean we could even take some. So we'll have to make a decision there. Yeah.
Yeah. I understand that. I mean, yeah. So I hope that I'll be able to do that. If not, then I'll have to fall back on something.
Correct. Yeah.
That is the only thing that I can see right
That's
now.
right.
Yeah.
So that's something that you'll have to do. Or what you can do is maybe you will come up with something, but no other thing. And then in that case, even without any reasonably tuned properties, we don't want to spend too much on the frequency network. Then we might have to end up taking two networks. Okay. Two
Right.
examples which are not high quality networks. Okay.
Right.
And show the application, which is also because your partner, Shogata, is going to be spending mostly in getting those networks, correct?
Yeah.
Ready, and therefore maybe you can do
Yes, sir.
chips plus this thing. So that's a suggestion that I have, okay, based on how much progress that you can make on the thing, and which I can help you as well in trying to one of us, Madhukar, I can help in trying to see if there are some general properties at the first level that you can do. Okay. So we are getting late, so I think we should give some time. Yeah, this should be fine. All I want you to add is some details about what you have described in here to the proposal, okay, and your the plan part, the plan that I just now proposed, suggested, yeah, into the
Right.
proposal.
So that plan would basically be try and find a general framework, and depending upon the success of that, either focus on that or focus on
That's right.
applying it to multiple networks, right?
That's right. Yes.
Yeah. Okay.
And that will be decided within a week or so.
Yeah. Okay.
That should be fine.
Sir, I have to leave by 5 p.m. So can I just present? Can I tell you another idea?
No. I think we will. Okay, Sahil. No, Sahil is not here.
I'll stop sharing.
I think Rubin had presented his idea in the previous lecture.
Yeah. Now I think all the other people. This is kind of the second time they have actually made a proposal in written proposal, and therefore we already had some idea. Okay. No, it is very important that we have to listen to you. The question is whether to do it in this session or post a separate session. Okay, is the question that I'm raising. So that depends on Zubin's thing. Zubin, what do you want to do? Since Sahil is not here.
Yeah. So we've been thinking about a lot of ideas, but I've just
because either since Sahil is also not here, and I want both to be at least present, even if one of you is presenting it. So it would be good if you could put something anyway you have to put it on paper. Okay.
Yeah.
Put what you have on paper.
We have a new idea different from the one that we had before.
Okay. Is it completely different or within the same framework?
It is quite different. It's along the same lines, but it's quite different.
Okay. So, do you want to do it when in Sahil's presence? Then I will go and give the time and the rest of the time.
Yeah, he's traveling today or something, he said. So, we can do it with...
for that. Okay, Kapil? You have 10 minutes. Yeah?
Okay, sir. What another idea I had thought of was we'll work on the MNIST data set, which predicts predicts the handwritten digits, whether it is 1, 2, 3 like that. And one property that we can verify is given an image, can we find another image which is within certain the L2 norm between these two images is bounded by certain number, but both images are classified differently. Hello, sir.
Yeah. Can you repeat what you said? So what is
there will be an image.
Yeah.
We will try to find another image so that the L2 norm between these two images is bounded, say less than 0.1,
What is
0.01.
an L2 norm? I don't know what can you explain what an L2 norm is?
L2 norm between two vectors is just square root of, okay, means if one vector is a1, a2, a3 and another vector is b1, b2, b3, then L2 norm is a1 minus b1 square plus a2 minus b2 square plus a3 minus b3 square, the whole root.
Okay.
So L2 norm between these two images should be less. So it's like they are not much different from each other, but still a neural network classifies both of them as different. The only problem I thought with this was the image is quite large, like 28 by 28 pixels. So I was not sure whether Z3 will work in this case. Means
No, Z3 working or not, that depends on your network size. Okay.
yeah.
So that in itself depends on how much
And another reason I did not propose this, I thought it was too simple.
too simple from a network design point of view, you're saying.
Yeah, I thought you would say that.
Yeah, and Kapil, I think it is very similar to quite similar to what I did in the ShapeNet thing.
Exactly.
That there was a square and I was trying to find an image, right?
Yeah.
Yeah. So the problem would be that you need to come up with more properties. That what are the other properties? I think you should work on them. Like try to figure out more 6 to 7 properties that you can check with this network.
Okay.
Yeah, but what does the neural network itself do here? I mean, it will classify.
Classifies the digits.
Output is 1 or 0.
Classifies the
If
image.
it is if the L2 norm is below a certain value, then it is.
No, given an image, it classifies whether it's 1, 2, 3 or till 90.
Professor, so it's exactly like the digit net. It's actually the same thing that we did in the class.
Recognizing the digit. Okay, so
Yeah.
I got confused with the L2 norm definition that he had because there was no such thing that was actually used by you, no?
Yeah, so by L2 norm, he basically means that how the image differ. He's trying to quantify the
Basically,
difference.
we are trying to find adversarial examples.
Okay.
So there are two images which look very much similar but still are classified differently.
Yeah, okay. No, but this might be from a network design point of view. This could be made as complex or as simple as you want, no? So from that perspective, it is okay. So, but your concern, Hitat, is that whether there will be enough properties for this?
Yeah, so he just mentioned one single property. So my question was, what are the other properties that you can come up with this for?
Yeah, Kapil, don't worry about Z3. I mean, this being too difficult for Z3. I want an interesting, what we want is some interesting thing for which, it is interesting for you to work on designing and then developing the network with reasonable accuracy. And then you'll be pushing the Z3 verification. As long as you can identify the properties, so that should be fine. But will you? I mean, you'll be applying this thing for a certain kind of images, or
Yeah, certain kind of image.
yeah. But what would those images be like?
We will try some MNIST dataset first, recognizing digits.
The data set, it will be an image of handwritten digits, 28 by 28 pixels.
Yeah, it will be much like those squares example that.
Yeah.
Huh?
Yeah.
So that your concern is that it will be too simple.
Yeah, that's the thing. Yeah.
But by choosing a more involved images rather than just squares, can this be made a bit more complex?
I, I I think Kapil, I think you should take you don't need to just come up with this new proposal right away. Like I think you can take some time and maybe come back to us tomorrow with something more concrete. I mean,
Can we
I yeah.
come back 1 2 days later? I would like to discuss with him. Sometime.
Like what you again? Can you repeat what you're saying?
Can we give the final proposal next 2 days later?
I think that's up to Professor if he's well.
No. I'm, because this is, we'll have to do it, at least at the proposal stage, that I'm okay with giving, a couple of more days. That is fine. But is it better to do it, with a consultation rather than you go away for 2 days and then?
I would like to discuss with him for some extended time.
With that, huh?
No, with Kapil and him.
Okay.
And say tomorrow or day after tomorrow.
Yeah. So day after tomorrow should be fine.
I think we are putting a more strict deadline for 31st, if I'm correct. That is what you were hoping, that 31st would be the last date for proposal. So it would be good if you can, come up with something, rough idea, give a rough idea to us by tomorrow, and then maybe we can discuss day after tomorrow.
Is that okay?
Okay.
All right.
Okay, sir, I'll have to leave. May I leave?
Okay, fine. Thank you. Yeah. It's 5 o'clock, so I'm not going to insist the people to try. So Zubin, what have you decided? So people can leave if they wish, if they want to.
Okay, so should I share my screen?
Yeah, let me. Yeah, there's no restriction that people other than, Hitat and Madhukar will have to say. If you want to stay, you're more than welcome.
I'll also get a glass of water. I'll take 2 minutes.
Yeah, please.
So I just wanted to clarify, what do you think is a good time within which we should make the
1
decision
week.
on
1 week.
1 week. So next Wednesday, I guess.
Yeah, next Wednesday, Friday is when, okay?
Right.
No, I'm saying next Wednesday, Friday, we can, I'm willing to, we can discuss in between, okay?
Yeah, I will. That is fine. Yeah.
Want us the thing? I think so. Yes. 1 week at the most, Friday. Yeah.
Right.
You will need some time also. No? This will be part of that effort. So at least the decision as to whether how much effort you will make this as the main or significant effort. Some goals to this part of the thing, so that we can design your structure your project so that there will be enough work in both parts.
Yeah. Okay.
Okay, should I start?
Yeah.
Okay, so we've been looking at a bunch of ideas, but
why did you decide? I thought that idea was
we don't know how feasible it'll be, but I think we found a better.
Madhukar suggested, was Madhukar thought that would be difficult.
Yeah, so now you can see my screen, right? I'll make the font bigger. So I've been working on this program synthesis kind of tooling for some time. So this doesn't use SMT or neural networks, but it's so we have some function definition given a function a to b, and either a or a c. We want either a b or a c. So we fill this in with a so these underscores represent a typed hole, as in it's just a hole that the compiler can tell you the type of. So it says this hole has this type, and it's a hole in the program. It's not filled in basically. So what we want to do is generate a program that will have this type and fill in this hole. So we can ask.
So this only has to meet the type constraint.
Yeah, this right now only has to meet the type constraint, but I'll talk
any
about
fancy specification or anything.
no, not right now, but I'll get to that later.
Okay.
But this only has to meet the type constraint. So if we ask the editor, whatever, we can ask the IDE I've been working on for suggestions. So it says, or you can fill it with bar. So this is a very trivial recursive definition. X equals X. This is recursive, so it doesn't really make sense. Like, it's not a good definition, but there are a bunch of, so you can refine it with further holes. So some function applied to some hole. So now this hole has a different type. Now this hole is of type this. Or you can, you can replace it with any of these options. And the thing I've been working on recently is you can try to get it to automatically generate definition using this attempt to fill hole thing. So if you do that, it'll try to fill in the program, and it's succeeded. So it pattern matches on this either. If it's a left alternative, it maps the function on that. Otherwise, if it's a right, it can just return that. So this thing is of the correct type, and it's filled in the program. So it can fill in a bunch of programs like this. If I change, maybe if I do CD, if I want to change the C to a D also, and I pass it another function, C to D, I can get it to fill the hole in again, and it fills the hole. Uh, this time it maps over both A and C. So it uses FAB to map over A and FCD to map over C.
So here you're giving some restrictions on the form of the expression, is it? For it to
so the way it works is there are a bunch of tactics that we use. So this attempt to fill hole is something like an auto tactic, which tries as many tactics as it can using heuristics. But this is like a one-step tactic, introduce lambda. So this just does one step. It just introduces the lambda, the outermost thing, and gives you another hole. Then you can do a k-split on the lambda, on the hole inside the lambda, and get something. Then you can fill this in, and then you can fill this in. So you can do it incrementally, or you can do it all at once. So this is something I've been working on with these guys, with some people. But the problem with this is one problem that you pointed out, that this doesn't really. So this can get something of the correct type, but you can't really give it anything more special about. You can't tell it any properties that your value has to satisfy, like your function turns a positive into a negative, or returns even numbers always, or something like that. So sometimes you want to constrain your search space according to some kind of property that you might find useful. Other problem is the search space is like very large. So we had this bug recently. So we had so we had this test case over here, which seems to be very simple. It takes some effect producing an int and some effect producing an A, and you want to return some effect producing an A. So one possible thing is X, Y, and just return the second one. it's like the constant function kind of, or yeah, just return the second one. You ignore the first argument and run the second one. Another option is you you run the effect in the first argument and then you do the second one, or you can uh, run the effect in the first one twice and then do the second one, or so on. So there are lots of possibilities over here. So the problem that was happening was that when we do it in the editor, it works, but when we do it in like our CI environment, it the search space is so large that it just times out. So uh, for the other problem, let's see, yeah. So this is one part of it. The other part is okay. So there's something called liquid Haskell, which uh, adds refinement types to Haskell. So what refinement types are they are basically uh, they are predicates on types, or they constrain your types in some interesting ways, and then use SMT solvers use an SMT solver to uh, verify that your program matches the constraints. So uh, so these things are normal Haskell definitions. These things in the comments are annotations for liquid Haskell. So these are special. So negate is a function that takes an int and returns an int. Its definition is just -x. But so its Haskell type is just int arrow int. But in the refinement, uh, we refine the type further, so we can specify exactly what it returns. So we say given an x, which is an int, it returns a set of values v such that v has to be equal to x. So with refinement types, you can put some predicates on your types.
Dependent type.
So this is like dependent types, but it is done using SMT solvers, and it
because you have this predicate.
and it operates on a layer above the surface language. So you can delete these annotations, and you'll get a valid program in Haskell. But with these annotations, you can define a type of positive numbers, which are integers, such that 0 is less than all integers in this range. And you can define a type of negative numbers, which is again integers, such that they are less than 0, less than or equal to 0.
In this case, there is a trivial solution for this, because you can the dependent type. I mean, the predicate in here really suggests what your
so it suggests the exact value. So you can do things like this. So let's say I have a function foo is int to int. So foo x equals x is a valid definition right now. But if I uncomment this, so it says it has to take a positive number and return a negative number. So as soon as I uncomment this, it gives me an error saying the infer type 0 is less than v and v equals x is not a subtype of v is less than 0. So it requires v to be great. So the infer type is v is greater than 0, since it takes a positive number over here. But the type it's expecting is negative numbers over here. So it gives me an error over here. So so this program doesn't type check because of liquid Haskell. So if you build this, it checks some sorry. So it fails to build because liquid Haskell is not happy with the program. So one possibility is so we can add in a hole here. So our hole fit plugin currently does not interact with liquid Haskell refinements at all. So if we attempt to fill hole, we'll get ID again. So it generates the trivial definition. But liquid Haskell itself has something to generate to synthesize programs. So if you enable this thing over here and go over here, So now it gives us a bunch of suggestions for what we could fill the hole in with. So it could say we can fill it with negation of x, we can fill it with -1, we can fill it with -x plus x. So these are all synthesized definitions that satisfy the constraint, and they're generated using Z3. So these are all the possible. So minus, so yeah, -x -1.
But this is
So all
not
of
an
these.
exhaustive.
These aren't exhaustive, but these are some bounded, like some number of models that it got, which could satisfy it. Yeah. So, but again, our attempt to fill whole thing is not really aware of these suggestions, so it still attempts to do X. So the first part is a bit of engineering where we teach our uh, IDE tactic solver about these constraints and guide its search based on programs that satisfy these constraints, and uh, these liquid Haskell constraints, and also uh, there are models for sorry, yeah. So um, so because the search space is very large, we don't want to just keep applying tactics at random or based on heuristics. We want to use a neural network to tell us which tactics are good, or which tactics will actually make sense and give us.
Where is the tactic used here?
So over here, okay. So the tactic is so attempt to fill hole is a kind of tactic, but
Yeah, but you said that Z3 already suggested a bunch of solutions. Why can't
Z3 suggested a bunch of solutions. So those are not using tactics; those are just using the SMT solver.
Yeah, that is.
But the earlier thing I showed you where
and a model, something.
Yeah.
Yeah, it's model generation there. Correct?
Yeah. So if I want to map over a pair this time, let's say I want to turn A comma C into B comma C bar equals. So over here,
Now I think okay. By the way, Hidat and Madhukar, I mean, we have to check their availability as well. Okay.
Okay.
So, what do you think? We should, what are your constraints?
Yeah, so
I think
I'm
5:30 is like I cannot go beyond that.
Half an hour, 15 minutes.
15 minutes for me.
Yeah, Madhukar, that's okay with
yeah,
you?
yes, sir. Not concerned.
Yeah, based on that, you have to define the problem. So if you want, then we can have another session. You write up something, we will look at it. That's what I suggest. Okay.
Okay.
It's just a quick intro.
Yeah.
Find the problem, and then you will have to.
Yeah. Right? So the tactics that we were using here. One sec. Got into a bad state. I'm restarting.
Yeah. Now, I think I kind of understand. So the solution that you had is something that, like you were saying, see, it's counterexample guided synthesis, right?
Yeah. Yeah.
It does, it reduces that into eliminating some, existential quantification, and then it does in using repeated SMT solvers, and then explicit, as the solution will be any model.
Yeah.
That. Now, but that is okay. So you want to change. Yeah, that is not what you want to use, but you're suggesting something else.
Yeah. So
quickly, what that thing is? Yes.
So we have tactics like we can introduce a lambda over here. That is one tactic, like the intros tactic in Cork or PVS or whatever. So we can introduce these two arguments. Then another tactic is a K-split or a homomorphic K-split. So a homomorphic case split means the result type is the same as the input type. Whereas, so if you do a case split, we get result thing is just a regular hole. It can be any kind of hole. It might be a pair, it might not be. But if you do a homomorphic case split, it constrains the result to be a hole. So we have a bunch of tactics that we're working on.
But when you apply this tactic,
Yeah.
what is the goal? I mean, it is preserving.
So the goal is this type over here.
Still, it is type. Okay.
Yeah,
Yeah.
it is a type. Yeah.
But you can add.
Yeah, so we can add the constraints from liquid Haskell to the goal.
Okay.
So that is not done yet, but
You could, but right now you're using simple types. I mean, Haskell.
We're using just Haskell types, but we could add say more complicated the actual liquid Haskell, these types with predicates and things like that. So we could do that, and while we're searching for these solutions, we want to use a neural network. So this paper I was showing you. So how this works is there's a synthesize step where it tries, so that if you have a program and so if you have so you write a SMT formula like this, there exists a program P such that for all X, the program satisfies some property sigma.
Yeah.
So to synthesize, you generate a model for P, and then you generate a model for P using a particular set of inputs. So you take a finite number of inputs, you sample a finite number of inputs, get the correct outputs for those inputs. And so if you say F, if you want, so if you have declare fun F int, then you wanna and suppose this is the function that multiplies by 2. So then you will say assert f of 0 is 0. Sorry, whatever. So you give it a finite number of inputs, assert equal to f of 2, 4. Give it a finite number of inputs, then generate a model using that. And then you'll get a model like this. But this is not the model we want. We want it to satisfy some property. So we verify that property. So if we get a counter example, so suppose our property is assert for all x int equal to x plus x, something like this is our property. Then if we again check sat, sorry, check sat and then get model, we'll get a counter example. So no, sorry, we use the model. So once we've generated a model, we add a counter, we try to verify it. If we get unsat, that is the verification succeeded, then our solution is the model we generated. Otherwise, if it's satisfiable, that means we found a counter example C. So we add that counter example to the list of inputs we had. So we had 2 inputs. If we got a counter example, we would add that counter example to this list of inputs, and then try to synthesize again and repeat this until we get a solution.
Getting in the like a bunch, I mean, lot of case splits. One example that you generate. Okay.
Yeah.
So make it quick. So since we can't, so what is your final goal? So given that you already have this thing.
Yeah. So the first would be to teach our tactic thing about liquid Haskell constraints and use the SMT solver to guide generation of
Yeah, but
or
that,
to guide hole filling.
yeah, but there you
Then
have to use a neural network or
so the neural network will be used for telling us which tactic to apply at which point. So uh,
yeah,
or
there
as
the
a
goal is
heuristic,
just the type. The goal is just the type. So you
the
want
goal
to
is the
create
type
a
with
session using a bunch of tactics.
yeah.
Such you will do, because not all combination of tactics might get you. You will have to,
Yeah.
in general, enumerate lots of different things.
Yeah, yeah, and the search space is very large, so we want some kind of
Yes.
heuristic to guide us, which the neural network will provide.
Yeah. Yes. But why did you bring this paper?
So they are actually using a neural network to do program synthesis using this thing. So for training data, so they gave an idea for generating training data also.
That is also
So
fine. And what is the problem that you will be trying to solve? This is another proposal that you.
No, this is part of the same thing. So I'm using techniques from this paper in our.
Oh, I see. To solve the other problem is what you're
Yeah,
saying.
yeah.
Okay. So in designing the network, but of
Yeah.
course here they are solving it for for an arbitrary predicate, right? Or for some predicate.
So they're doing it for predicates over bit vectors, or they're doing it for programs over bit vectors.
Correct. But what will be your predicate for the problem that you for the Haskell? The Haskell.
So the predicate will be the liquid Haskell predicate over here. So like over this, it has to take a positive number and return a negative number. So the result has to be less than 0 in this case, or given a number that is So we assert that the input is greater than 0.
Predicate will be generated. How will you generate the predicate?
So the predicate will be will be given to us by the user of the tool. So we have a lot of test cases in the liquid Haskell thing. So
predicate will be given to the thing. Okay, that's okay.
Yeah.
So yeah, that is some. Yeah, so I think I get some idea. Okay, but you will have to write. Okay.
Okay. Yeah.
One-page thing. Okay?
Yeah.
In order for us to evaluate this. Okay.
Okay.
I mean, I'm willing to do that. We are, with the help of Madhukar quickly. Okay.
Yeah. Okay.
Maybe Hitarth, I mean, you also looked at some of this paper, no, didn't you? While you were, trying to do that verification thing.
Yeah, I mean, maybe not exactly this paper, but perhaps. But I
before you decide on that, you might have looked at it. Oh, no, not this one though. Okay, now what I had was here they seem to have an actual neural network based approach. Okay, this paper we have not looked at. Okay, so I think what you should do, I think we can wait for a day. Okay, I mean, it doesn't have to be very polished, Zubin. Okay.
Okay. Yeah.
So that we can quickly see what this thing is about. I got some rough idea, but there are lots of questions I have. Okay. So I think you will. I mean, writing something, even if it's half page, and then maybe sending the other paper, give the other.
Yes, I had a question, Zubin, that will it also involve verifying the network that you will be creating, or it will be just like creating the network for this particular?
No, it'll verify the output. It'll verify the output of the network. So the neural network and the SMD solver will work in tandem almost. So
okay,
the
so
neural network will generate something.
You're using network to just get you to the tactic that can be used to fill in the hole. That's it, right?
Yeah, and
you're not verifying how. I mean, do you also plan to use to verify the network that okay, it's working correctly on this range of input, or like for example, this kind of programs and so on?
I don't think that will be possible for any non-trivial network we
Yeah.
have, and for any heuristic that we. So any heuristic will have to be non-trivial that we use.
Yeah, Professor. So I had this concern because all of the projects actually involve, verifying a network for some, like the network is working for these kind of inputs. But Zubin's project is like, falls in like an odd man out. So it's something very different than what everyone else is doing. So that's something which we should like note carefully.
It is
So
the training of the network.
so in the end, though, whatever tactics the network generate, it has to be passed, like the SMD solver has to verify those that they actually solve the, or they actually fit the program, the constraints.
The SMT, so there is no need for verification, is what you're saying.
Yeah, I mean, yeah, because in the end, any output has to be valid because.
So, but your network might not find a solution.
Yeah, it might not find a solution. That is a different thing. But any solution it does find will be guaranteed to work.
Okay.
Correct.
Yeah. So this is the blog post the person I'm working with wrote about these tactics.
Yeah, but is there some, even when it doesn't find a solution, I mean, but in general, is there something that, like progress, or it is eliminating certain things?
I mean, in general, it's undecidable, I think.
No. That's why I'm saying, can you verify some site properties that ensure certain things that you expect the
I think that'll depend heavily on the kind of architecture for the neural network we end up using, and whether it's feasible or not also depends on that. Because if you're going to use any kind of useful heuristic, the network has to be pretty large. So it's doubtful that we can verify any non-trivial kind of properties.
yeah. But the challenge here is what then? I mean, it is in
It
design.
is in the design of the neural network such that it can take it. So first it's designing an input encoding that takes all the relevant constraints and the available variables that it can use, the variable definitions that it can use, the inputs, and uh, returning a tactic out of a list that might apply. So first we have to generate an architecture for that. So this paper has ideas for that. So they encode sorry uh, yeah, so they have two layers. So they said the simple network didn't really work for anything non-trivial. It couldn't generate any uh, useful things. So it just takes the inputs and the outputs, passes them through a bunch of hidden layers, and returns. So they have a predefined list of 100 tokens that can be used in their program. So like a if or a variable or something, and the network returns a number from 1 to 100, indicating which token it's going to use. So this didn't really work for them. So then they went to a um, two-part model. So where there's an input encoder, which takes the input in the examples and generates internal encoding of that, and then they have a decoder which actually does the synthesis from the encoding that the encoder generated. So yeah, so they ended up with a pretty complicated kind of architecture.
Okay.
So
I don't think I can come to a decision today.
okay, we'll try to write something up tomorrow, day after, depending on whether Sahil. He said he's traveling today, so I don't think he'll be able to meet today. So Friday, I think by Friday we'll have something for you.
Yes, something. I mean, I also discussed with Madhukar and Vikas about how to, if we accept something along this line, which where no verification is involved, then it has to satisfy some of the criteria. Okay.
I mean, yes, but we are verifying. So this is similar to that, the idea that Madhukar had for generating induction invariants.
That is true. That is true. But
So
there,
this,
I thought that you could. But
I mean, even there, I think if you did any kind of non-trivial generation, it would be difficult to verify any useful properties about the network.
no, no. I mean, either if the verification, I mean, it can end up generating something which does not satisfy the thing. No?
Yeah, in Madhukar's case.
No. Even in that way, whatever neural network that you design, it may not do.
Yeah. Yeah, it might not work very well or at all. But whenever it does work, we know that we can verify the output of it. So once we have some output, we can verify that the output actually works. Might not produce an output, that's a different problem.
Yeah, but then if that is the case, you can come up with some things. I mean, under these conditions, does it always produce some results? I mean, that those kinds of
Those
things.
are those are just test cases, right? Under these conditions is like you can
Yeah.
have a number of test cases, but not like a
Why? Why?
general predicate on inputs, because I don't know, the input space is pretty complicated and you can't really classify it in that sense.
And how do they even measure the effectiveness of these neural networks there?
So we can take all these liquid Haskell test cases. uh, so there are synthesis test cases, and so liquid Haskell has a bunch of these test cases, so that it there's an insertion sort program. You want to verify that the length of the input is the length of the output, and all of these things.
Yeah. See,
So
then
we can replace parts of them with holes, and
since it is different, you know, I'm going on a limb. This is I'm giving my view. Okay, so I'll have to discuss with the others if they comply. And well, then you will have to justify, produce some high level.
yeah, so we can give you a list of benchmarks or a list of examples where, or list of say 1,000 examples where out of 1,000 it could generate the program for 600, 700 of them.
Generating is okay.
No, it could generate and verify the properties for 600 to 700 of them.
What do you mean? There's no verification. You just know said there's no verification possible.
There is verification that, okay, so when you generate a program, the liquid Haskell specification that we are given, like over here, it says, given some input list, return an ordered list. So an ordered list is like this.
Why
Is
did you
specified.
verify that? Because you just know said that by construction, this always, if it works, it'll always produce the thing.
No, we have to. We can verify. That is a later step, right? If it doesn't actually satisfy it, we just report to the user, "Oh, this is not work."
So it can go wrong.
It can go wrong, but in that we can detect that in that case, and we don't output that program to the user. In the end, we always do a verification pass over the generated program, and if it doesn't work, then we just don't report
Those
it.
things are output verification, not the neural network verification. You're not verifying any property of the neural network, correct?
Yeah.
Yes. Okay. So I think we'll also discuss and think. Yeah.
Okay.
Azubin.
Yeah.
You got my email now? About tomorrow's model checking class. What I wanted.
I don't think so. Let me check.
On essential.
Okay, I think we can leave now, right, Professor?
Yeah, you can.
All
Yes.
right, all right, thanks. Okay.
Yeah,
Oh, I
please
got it.
leave, okay? Because this, I'm just discussing something else with Zuba.
Oh, yeah, I got an email. Yeah, today morning about.
Is it possible by tomorrow?
I don't think by tomorrow because I have another presentation tomorrow,
Okay, fine
and
then.
then I have to
Yeah.
work on this also. So
Yeah.
I think the weekend I will be able to do it.
Okay, fine.
Okay.
Yeah.
Okay. Bye.